right? So what did we do? We had these 16 variables, right, relating to pollution, but we didn't actually do the PCA on all 16 variables. On all 15 variables, I should say. Oh no, there are 16 variables, yeah. On all 16 variables. Why is that? The 16th variable was called mortality, right? We were interested in that as potentially as a target variable. So we want to do basically the PCA on all of the variables, starting with, let's actually look up practical pollution. Let's bring that here. Precipitation all the way up to humidity. So these guys here. So that's what the code is saying. It's saying this thing here, do the PCA, start at the variable prec and at humid, right? Everything in between. You'll see that mortality is the last variable, so it won't be included in that, right? This ID mort variable, this ID mort line is basically saying, hey, look, okay, give me the results, and then give me the value of mortality on my PCA plot. So the output was then, wrong one. Where was it? Did I run it? I did, didn't I? Okay, yeah, I did. Ooh, that's the piece, that's the print ball. That's down here. The output then was my PCA1 and my PCA2, my PCA plot, right? And with every data point, we actually had a value associated with it. And that was just the associated mortality for that point. So we can see that we have unusually high mortality around here. This is sort of an unusual data point with respect, not with respect to mortality, but with respect to the 15 variables that we've used to characterize these areas. Okay, so it was unusual with respect to these variables that were here. It had a very unusually high nitrous oxide, very high sulfur oxide, very high density, because these are all vectors that are pointing in that direction, right? And that's where this data point is. Right, but the mortality wasn't particularly high, 861. In fact, it would be one of the lowest, right? 861.33, almost the lowest. This data point here. So the ID variable in this instance was just to see, okay, we're trying to characterize these geographic areas by all these socioeconomic and demographic things, and also rainfall, etc., and pollution values. But really, we're interested in relating that to that big set of X variables to mortality, right? So some of you might have thought, well, maybe a multiple regression would have been the way to go, right, to do that. But of course, we know that all these variables are highly correlated, or a lot of them are correlated with one another. So we would have had problems trying to create a multiple regression with all 15 variables in there, trying to predict mortality. So, okay. That was all I wanted to say about that, I think. Any other questions about what we've done with the bubble plots and about PCA? No? Okay, back to it, guys.